Hello students, welcome to Misostudy, and as it's clear from your picture that is present in front of your screen, today we are going to discuss class 11th very important chapter, that is waves, and that too questions based upon JEE main pattern. Fine. So without wasting any moment onto some sort of sermons or discussions, let's start these questions. Because you are preparing for JEE mains exam, so mathematics is one of your subject, so there is no problem if I'll use some sort of quick explanations, or I may jump certain steps because detailed solutions are going to be provided. Fine. Here my aim is going to be provide you the clarity of the concepts. So here comes your first question. At what temperature the speed of sound in air becomes double of its value at 0 degree centigrade? Fine. As such, nothing is required over here to explain you, only you have to apply a formula, and that formula is V sound is equal to gamma RT by M. Universal gas constant, this temperature, gamma is ratio of two specific heats and M is molecular weight. Now, at what temperature means gamma, R and M both are not required. Reason being, you have to write down this formula twice. That is velocity of sound number 1 at 0 degree centigrade, that is 273. You have to add that value in order to convert it in Kelvin, and V sound number 2 at some specific temperature when the value of sound is twice of that of previous condition. So it is 273 plus T. Accordingly solve it and you will get final temperature is equal to is equal to 819 degrees centigrade. So in this question, what exactly important? Why I picked this question? The reason is simple. Please be comfortable with the basic results. Fine. Otherwise, in examination hall, slight confusion may create some sort of difficult problems. Just to emphasize this point here, again a new question I am picking with the same type of idea. What is that question? The ratio of velocity of sound in hydrogen gas, hydrogen gamma is equal to 7 by 5, to helium gas gamma is equal to 5 by 3 at same temperature. Fine. So let's take a look. V sound gamma R T by M. Now in this question it is given temperature is same, so this term going to cancel in two relations. R is gamma 1 gamma 2 given, M1 M2 is also given. How? One is helium gas, another is hydrogen gas, so simply you have to put the value of molecular mass, solve it. Now answer is 42 root by 5. Not important. Important is what? This formula you should be comfortable, and also how these terms are changing. Also you should know that this is Laplace correction, because initially what Newton said propagation of sound waves in gas is a isothermal process. Fine, but the result experimentally was not correct. Laplace introduced this correction. He said propagation of sound waves in gas is adiabatic process. So you should know that concept and this formula, that is only required over here. Fine. Next comes is question number 3, and this question number 3 is based upon a very important concept. What is that question number 3? The vibration of wave represented by y is equal to y naught sine kx cos omega t What I said, I not read this equation. I mentioned the standard equation. Fine. Then maximum displacement at x is equal to 5 centimeters. Okay. So let me allow to write down that particular standard equation. Why I initially mentioned that this equation is very important? Reason being, if you know the standard equation, this question is very simple, and if you have some confusion, it's going to be difficult one. Okay. So let me allow to mention it. Y is equal to y naught sine kx cos omega t. Compare this question with this equation. Similar? Okay. But you have to find out not this y naught, but you have to find out maximum displacement when x is equal to 5. Just take a look over here. No need to write. 5 place over here. 5 1 is 5, 5 3 is 15, pi by 3. Sin pi by 3 means root 3 by 2, sin 60. Fine. So that solve it and you can get the value. For maximum value, let me allow to write down. I can say that it is going to be y is equal to 4 sin pi by 3 into 1. Few of you may say, how exactly 1? Oh, maximum value of sinusoidal function is plus minus 1. So maximum value of cos 96 pi into t is 1. Now see the beauty, so beautiful explanation. Pi by 3, that is 4 into root 3 by 2. Oh, answer is nothing. Simple. So you can say B is the correct option. Fine. See, few steps I am not solving. Reason is simple. You can solve these trivial mathematics involved over here. Simple some values, or you can say some formulae. Fine. So that's why I am not devoting any time over there, but devoting some time onto the clarity of the concepts. Now here comes next question. Students, one thing you should realize for this particular chapter. In this particular chapter, that is waves, actually in the concept of, you can say, organ pipe, closed organ pipe, open organ pipe, speed of wave in a medium, these type of concepts normally they don't liked by the students. And here it is not important you like the concept or not. Important is you have to like it, you have to learn it, you have to solve it correctly. That's why I am picking now those questions. I mean, these questions create some sort of repulsion in your approach. So please try to be familiar with these things. Try to make them your best friends. Fine. Let's try to understand how. Speed of wave in a medium is v, meter per second. Forget about this number. Let's try to understand the concept. If this much waves passes over a certain point in 1 minute, it means what? 1800 divided by 60, that will give you the frequency, nu, f, n. Then what is the wavelength? So ultimately we are looking for lambda, while v is given, and the basic result we know, nu is equal to c upon lambda. So from there I can say f is equal to v upon lambda. And what is the value of f? F is 1800 divided by 60. Fine. So let's use this relation. Lambda is equal to V by F, V by F, V by N, fine. Now, value is 900 upon F, and for F 1800 upon 60. Put the values and you will get lambda as 30 meter. Fine. So, as such you can say these things are not difficult, basic formulae applied, fine, and then you can easily find out the correct solution. Point mine is here that at any specific instance you should be comfortable with the formulae applied, fine, because if in these type of questions slight confusion in formula, once or twice some sort of mismatch in calculation, be sure in examination hall you will not able to secure correct option, fine. One or two incorrect options with these type of questions and you will lose your track. So, never ever allow that, fine. And in some manners I am trying to introduce some questions based upon organ pipes, closed pipe, open pipe. Here my simple suggestion is, if you are regularly watching our videos, I mean videos from this Misostudy, then definitely you will find we devoted good amount of time on these type of topics, fine. Here some sort of translation is required, harmonic, overtone, closed organ pipe. So, what exactly the meaning, that is important. So, first is you should know what is overtone or harmonics or idea of closed organ pipe, idea of open organ pipe, how it is going to be different in terms of formula application and so on. So, for that please, if you have some sort of confusion, please go back for the, you can say, watching of these videos which we already provided you. Okay. So, let us start analyzing this question. Third overtone of closed organ pipe. Closed organ pipe, important aspect. Third overtone, these two words will decide our further action. Is same frequency as fourth harmonic open organic pipe, ratio of lengths of pipes, fine. So, let us try to apply the formula over here, and do not worry, I incorporated two questions based upon this type of concept. So, both I will explain you, fine. I hope things will be clear to you after that explanation. So, let me allow to write down few sentences. Third overtone means, seventh harmonic, that is catch line. If any one of you has some confusion with this type of explanation, once again same suggestion, go for regular video, okay. Now, here I can write down lambda is equal to 4 by 7 LC, fine. What is the symbolic representation of LC? Length of that air column. Then F7, frequency of the 7th harmonic, F7 is equal to V by lambda. Here I am just introducing the formulae and concepts. I know calculation is not a problem for you, but unless and until you do not have the awareness of these type of concepts, formulae, where you can calculate, what you can calculate, how you can calculate, fine. So, lambda is equal to 4 by 7 LC and F7 is equal to V upon lambda. Now, replace this value. So, simply I can write it down, F7 is equal to 2V upon L not. All these terms deliberately I am explaining, I am putting so that I may force you to re-watch those videos, and by that way you can attain some sort of surety. Fine. And after solving this 7, and another is F4. Fine. So over here it is going to be F3, F4, whatever overtone is given. So for that you can apply the formula and then you can put the value of LC upon L0. So 7 by 6 is your correct answer. Now few of you may here say, sir, why we are not providing the entire solution? Calculation I said you can do. My point is only to introduce that this is something which is important. One more question is here. I'll repeat the same calculation again, and then I would like to request you, after watching this entire video, try to pick some questions from here and there based upon open organ pipe, closed organ pipe, harmonics and overtones. Try to solve them yourself. Fine. And obviously I hope up to some extent you will get clarity of at least few concepts from these type of questions. Fine. So here comes this next question. Now phase difference between 2 points is pi by 3. Moment this type of question comes in front of your eyes, what you should do? You should first start thinking about that specific result that you can apply, and then you can put the values. Fine. If the frequency is 50 Hz, then distance between 2 points is how much? While velocity is 330 meter per second. What I'll do, let me allow to write down the formula. After that I will pick up these lines again and will try to fit the values as given in the problem in that particular formula. Fine. So what is the formula which you are supposed to use? That is, now there are two terms. One is path difference, another is phase difference. Fine. Path difference, you should know that. Phase difference. Fine. One is path difference, another is phase difference. So first thing you should do, don't solve this problem. Brush up your basics about these two simple terms. What is path difference? What is phase difference? Here I am writing this formula. Fine. Lambda is equal to V upon N or V upon F. Just 5-10 minutes back I used this result. Over here let me allow to put the values as 330 upon 50. Cancel. What you will get? 33 by 5, or you can say it is 6.6 meter. No problem. Lambda is this much. Now path difference, I think I should put the value of lambda here. Lambda is equal to 6.6 meter. Then I will write down the formula at this place. That is better approach. Fine. Path difference, in short, is equal to lambda upon 2 pi, lambda upon 2 pi into phase difference, phase difference. Now one important thing over here, either remember the formula in this fashion or remember the formula blue point here, replace 2 pi upon lambda and white point there, but one way. It should not be like that, this way, that way, confusion. Fine. So don't make this a simple concept anyway complicated, because these type of formulae, you accept it or not, they are really sometimes very difficult to get clarity in examination hall just because of the pressure. Moment you mention, oh, phase difference is equal to lambda upon 2 pi, part difference, ruined. You know that it is not correct, but just because of the pressure. So please don't allow these things to happen. Fine. Now, path difference and phase difference, if I can correlate, then I can write down 6.6 upon 6. Fine. Lambda value given 2 pi, it's going to be cancelled. So it is 1.1 meter. Now finally, lambda upon 2 pi into pi by 3, it is mentioned pi by 3, it will give you lambda by 6. Fine. So here this will give you the value rather than lambda. Put this 1.1, solve it, you will get in centimeters this value. Fine. So here important is not this calculation, anyone can do that, but how much comfortable you are in these type of formulas, that is important. And here nothing to understand. Why? You just have to do some sort of practice, that's it. Fine. Now let's move for the another problem. Equation of transverse wave on a rope. Here just listen carefully. For the time being, put it aside. What exactly I want to explain you? Put aside it. Let's try to understand in this fashion. Mechanical waves. Okay. Number 1, longitudinal, longitudinal. Number 2, transverse. Now why I am telling this? Reason is simple. Moment you watch these type of questions, just wait, I mean not in examination hall, but this is something while you are preparing. So read these questions, put aside, think about basics. Okay, so this question is from waves, that is mechanical waves. So they are of two types, longitudinal and transverse. Longitudinal means particles of the medium vibrate along the direction of the wave propagation. Transverse means particle of the medium vibrates perpendicular. So if you revise like this, you approach like this, then in one question you may revise at least 3-4 concepts. Fine. So even if you are solving only 10 questions, at least you are preparing perfect recipe for around 25 to 30 questions. Now anything associated with these concepts I may ask and you will definitely able to answer it. This is the approach in totality for competitive exams. Fine. So this way also prepare your small notes. Otherwise in videos, regular videos that Misostudy is providing, we tried our best to minimize your efforts. Fine. Now after this I would like to move ahead and I will tell you a very simple technique. Given by y is equal to this value, where y and x are in centimeter and t is in second. The maximum transverse speed of the particle in the rope is how much? Okay. Let me allow to write down the standard equation. The standard equation, why I am writing just below to this question, so that it is going to be present every time. Okay. For the time being, my head is hiding this amount of question, but don't worry. Y is equal to a sine kx minus omega t. You can write it omega t minus kx, kx plus omega t depending upon the directions, no problem. Now, this question is present, this equation is present. What we will do? We will compare this standard equation with the given equation. So, now A is what? 10 units. Kx you can easily find out. This omega t you can easily find out. So, approach should be try to compare standard result with these equations. Fine. Now, I will use this space to solve this particular question. Fine. My approach is simple. A is equal to 10 units. How we can say? Just by comparing the given equation with the standard equation. Okay. And omega is equal to 2 pi. Both facts just by comparison. Fine. Now, V particle and that to maximum. This is the formula. That is why I am writing is equal to A omega. Is this a difficult question? Not at all. Just compare it, use the values and solve it. Fine. So, you will get it as 63 centimeters per second. Now, this formula is important, but let us say you are unable to recall the formula, you just forget the formula. Okay, problem. What should be the solution? Y is equal to A sin I have right to write down omega cos. I hope you are comfortable now. So, even you need not to remember the relation for the velocity. Fine. For maximum, what is the meaning? Y max means velocity max. This is y prime, this is not y. This cos function should be 1. So, if it is going to be 1, so A omega. So, even if you are preparing by this way during your preparation, so be sure 100% you are bound to get correct answer in examination room. That is ultimately important. Fine. So, in totality, that is why I always used to mention that your approach should be in this particular manner. So, now let us move for equation number 8. The excess pressure in a travelling sound wave is given by P is equal to, close your eyes, listen my words, P is equal to P naught sin kx minus omega t. Close your eyes. Once again listen it. P is equal to P naught sin kx minus omega t. Now, let us take a look. P is equal to P naught sin kx minus omega t. Same standard equation. You just have to compare it. Okay? Where x is in meter, t is in second, p is in Pascal pressure. What is the wavelength and frequency of the wave? Now, few terms. K is equal to 2 pi upon lambda. Wave number. Okay. Omega is equal to 2 pi f or 2 pi upon t. So, now just by comparing with a standard equation, fine, and solve it, Fine. So after comparing this lambda is equal to 2 meter and frequency f is equal to 330 hertz. Simple formula, simple application. Now let's move ahead and go for the next question. Here I am not giving you any type of, you can say, a detailed solution, because I am giving you approach. So at any point of time you can solve yourself. Fine. Now it is next question, and this next question, as per my promise, is similar to that previous question. I think it was 4th or 5th question. Fine. Third overtone of closed organ pipe. Please take a look. Third overtone of closed organ pipe is in same frequency as fourth harmonic of open organ pipe. Don't take a look of that equation. It may be repetition. The question may be same, repetitive. It is just for you. Okay. At least I have this much freedom. This much freedom should be with me. Out of 10, I may repeat one question, so that you need not to go back to take the look of that solution, and you can easily solve that question. Here I am providing you again the solution. Third, and to be too honest, please don't take a look of that solution. Third overtone is equal 7th harmonic. Simple. Okay. Now lambda is equal to 4 by 7 and then LC. I don't know how much you learned from that particular question. Fine. So lambda is equal to 4 by 7 LC, and this implies that F7 is equal to how much? It is V upon lambda. Fine. So now it is 2V upon L naught. Even if few of you not learned that question, forget about re-explanation. So from here what I can write down, F4 is equal to F7. It means what? 7V upon 4LC. 7V upon 4LC, that will give you 4V naught upon, that is 2V, yes, L naught, fine. So 4V naught, 4V naught, no, upon 2L naught, yes. Either 2L naught or better to write it only 2, as I mentioned over here, L naught. Fine. So now after replacing the value, LC upon LO. Basically it is closed organ pipe, it is open organ pipe. So once you solve it, you will get 7 by 8. Students, please revise your concepts of closed organ pipe and open organ pipe properly. Fine. So this was a question which, just to give you some sort of, you can say, different approach, I used it again. Here an observer standing at the sea coast observes 54 waves reaching the coast per minute. Means F is equal to 54 upon 60. No problem in this part. If the wavelength of waves is 10 meter, fine, lambda is 10 meter, then what is the velocity of the water waves? Okay. So the same formula, that is V is equal to F lambda. Fine. You have to find the V. F it is given, you can solve it, you can easily get it, and lambda is 10 meter, fine. So, if by putting f and lambda values, v is equal to 9 meter per second. Simple solution. Now you may say, so these questions are slightly different but not as such difficult. Yes, it is true, they are not difficult. So what is required over here? Obviously revision. Fine. So I would like to suggest to all of you, please stop over here, give some sort of revision to this video at least once or twice. I hope when I will come back again with more good sets of questions in this particular topic, you will find yourself in a much comfortable and better position. So till then, take care of yourself, keep revising, have a nice time.